All right, so today we are looking at the algebraic analysis of externalities. The last time we met, we looked at the nature of externalities, and we said that we have externalities when the production or the consumption of a particular good has an effect on a third party, when a particular economic agent is engaged in an economic activity and there's an effect on another economic agent where the market doesn't actually consider that effect. Those are externalities. And as a result, we said externalities can be caused by either firms or consumers. So we have production externalities and consumption externalities. And also the externalities can be positive, can also be negative. So we have positive consumer externality, negative consumer externality, positive production externality, and then negative production or producer externality. So those are some of the things we discussed last week. Today, we want to look at the algebraic analysis of externalities, how we can use algebra to consider how efficiently goods and services can be produced to cater for whatever marginal damage that results from a negative externality for media consumption or production activity. Okay, so we are assuming that we have only two people in this economy, okay, just two individuals in the economy. And then the analysis will be based on a negative externality. So this is the case where maybe the consumption of a good by one individual will have a negative effect on the other person, or will reduce the well-being of the other person. So we have two people, and then we also have two goods. We have good X and then good Y. Good X is an ordinary good. It's ordinary because it doesn't generate any externality here. So we are taking, for example, food. Okay, it doesn't generate any negative externality. Then Y is the good that causes the externality. So we're taking an example as cigarette. So when you do this, though the second party or the second individual wouldn't be consuming some, there's a second-hand smoking, which is a negative externality. In other words, it reduces the well-being of the person who isn't even smoking some of the cigarettes. Okay, so those are the two goods that we'll be dealing with. Now, we are talking about goods, so we'll have to talk about how they are produced. The production possibility that describes, or the technology that is used to produce these two goods, is given by the equation x is equal to f of y. X is equal to f of y. So the quantity of food that will be produced is a function of the quantity of cigarettes that will also be produced. So here the first derivative, okay, f prime of y is less than 0. F prime of y is less than 0. It is negative, okay? And being negative means or gives us a picture or talks about the inverse relationship between the two goods, the opportunity cost that exists between the two goods. As you try to produce more, you have to produce less of the other, okay? Now, we use the negative of the f prime of y as the marginal rate of transformation. Okay, so if you take this PPF, this production possibility frontal, the marginal rate of substitution is giving us the negative of the first order derivative. When we talk about the marginal rate of transformation here, we are talking about the rate at which one good, okay, has to be sacrificed in order to produce a single unit of, or an extra unit of the other good. So here we can take the marginal rate of transformation as the quantity of food that has to be sacrificed in order to produce an additional unit of cigarette, or we can say is the quantity of food that we have to sacrifice in order to reduce the production of cigarettes by 1 unit. So the first equation here is the PPF, x is equal to f of y. Please, you can put it down somewhere because we'll be referring to the equations. And the second equation is the marginal rate of transformation is equal to minus f prime of y. So when you negate the first order derivative from the PPF, that gives you your marginal rate of substitution. And what does it measure? Okay, it measures how much production of good X, so here food, that would have to fall. So the quantity of food that we have to decrease if we were to increase cigarette production by just 1 unit. Okay, so if we want to increase the production of cigarette by 1 unit, then we have to reduce the quantity of food by the value f prime of y. Okay, f prime of y. And in other sense, we can see it as the opportunity cost of producing cigarette. Okay, if you want to produce an additional unit of cigarette, what is the quantity of food that you have to sacrifice? So the MRT is also seen as the opportunity cost of producing good Y. Okay. All right. So those are the two goods in question. Then the two persons or the two individuals. We have individual 1 and then individual 2. Let's use persons 1 and then person 2. Now, for person 1, his preferences is given by this utility function. Okay, U1 means the utility function for person 1. So U1 is a function of X1 and then Y1. That's the quantity of food and then the quantity of cigarette. Now, the marginal utility for good X, which is food, is given as U1X. Okay, U1X. And then the marginal utility for cigarette, that's good Y, is given as U1Y. They are all greater than 0. The marginal utilities are greater than 0, which means that when person 1 increases his consumption of both goods, it increases his well-being. Okay, it increases his well-being. In other words, he becomes better off by increasing his consumption of both good X and then good Y. Okay, both good X and then good Y. So to him, both good X and Y are just ordinary goods. Okay, so consuming more makes him better off. Okay, makes him better off. Now, the individual's marginal rate of substitution for one good in terms of the other. Okay, I'm sure you remember marginal rate of substitution. So if you want to find the marginal rate of substitution for individual 1, then it's the marginal utility of good Y divided by the marginal utility of good X. Okay, marginal utility of good X. And this is talking about the rate at which this individual is willing to sacrifice one good for the other. So it's how much person 1 is willing to pay for another cigarette or for another good Y. So let's keep this equation as well. Marginal rate of substitution for individual 1 is equal to the marginal utility of good Y divided by the marginal utility of good X. Okay. Now let's look at person 2. This individual doesn't like good Y. He doesn't like smoking cigarettes. Okay, so she tries her possible best to spend all the income on only good X. Okay, on only good X. So for today's individual, he or she, they are using she, so let's use she. She's trying to consume only good X. But let's not forget, good Y is cigarette, and it generates a negative externality. Okay, it generates negative externality. So though person 2 doesn't want to consume any good Y, he cannot avoid its effect that is caused by the consumption of good Y by individual 1. Okay, individual 1 sees cigarette as an ordinary good, so consuming more will even make him better. So he will try to consume more. But then individual 2, he doesn't want to consume any good Y. But because of the negative externality that is being generated by person 1, definitely he has to bear the effect of this consumption, the consumption of good Y. Okay, so if individual 2 doesn't want to consume good Y, then it means that as soon as he consumes some, it makes him worse off. Okay, and this individual is not directly consuming good Y. He's getting the effect, the negative externality, because of the consumption of good Y by individual 1. When individual 1 consumes good Y, it makes individual 2 worse off. Okay, it makes him worse off. So this individual's utility function is described by this. Okay, based on his preference between the two goods, we have this utility function. U2 stands for the utility function for individual 2. So here is a function of x, good x, okay, and then good y. Now, we know that he prefers consuming good x. So the marginal utility for consuming good x is going to be positive. It's going to be greater than 0. But he doesn't want to consume good y. So any consumption of good y makes him worse off. So the marginal utility of y is definitely less than 0. Okay, it's definitely less than 0. Now, if you look at this consumption function, it is a bit different from the normal consumption function that you know. Okay, how different is that? Now let's look at this. This individual doesn't want to consume good y. Okay, but he cannot also avoid the consequences of person 1 consuming good y. So what it means is that 1, the second individual's utility doesn't only depend on his own consumption of good y. He doesn't want to consume good y. So there is no y2 for that individual. But then the first person will consume y1. And then the second person cannot avoid the negative externality generated by the consumption of y1 by person 1. So the normal utility functions that we have, the total satisfaction or the total utility depends on the consumption of the goods by the individual. But for this one, the person's utility depends on his consumption of the first good and the consumption of the second good by a different person. So you see how different this utility function is from the ordinary utility function that we have. Okay, and then it's also different because for person 2, his utility will decrease by consuming y1. The first person is the person consuming y1, but then it is causing a decrease in satisfaction for person 2. But it's not like that with the ordinary utility functions. For the ordinary ones, you only benefit from what you consume directly. And most of the times, because the thing is a good, because of the axiom of non-satiety, we always prefer more. Consuming more will rather increase our utility. But here, it isn't so. When individual 1 consumes more, it reduces the utility of individual 2. Okay, so we are calling this negative externality that is generated by a person's 1's consumption of good y on person 2. MD, the marginal damage. Okay, the marginal damage. Okay, so whenever person 1 consumes good y, person 2 incurs a marginal damage. And then this marginal damage is described by negative U2y over U2x. In other words, it's negative marginal utility of good y for individual 2 divided by the marginal utility of good x for individual 2. You see the negative here. This whole ratio here is going to be positive. Why? Because U2y is less than 0. The second person doesn't want to consume good y. Whenever he consumes it, he gets his utility falls. So the marginal utility for good y is negative. So if you we have negative here with this negative here, then we are having a positive number for this. Okay, so the marginal damage is going to be a positive number. Now, what do we use the marginal damage for? It is measuring the extent of negative externality that is generated by the consumption of good y by person 1. In other words, it is measuring this damage is being measured in terms of food, that is the good x. So the marginal damage is talking about the harm that is being done to the second person as a result of consumption of good y by the first person in terms of food. Okay, in terms of good x, in terms of the good that the person 2 will actually desire to consume. So assuming we have a marginal damage of 20, then it means that the negative externality, the harm that is being generated by person 1, okay, for the consumption of good one is 20 units of food. Okay, 20 units of food to the second person. Okay. Now, what this means is that the value of the marginal damage, we'll be talking about the quantity of food, that's the quantity of good X, that the second person is willing to sacrifice in order to cause the first person to reduce the consumption of cigarette by just a small amount. So just assuming that the marginal damage is 20, it means that the second individual is willing to sacrifice 20 units of food so that at least the first person will reduce the consumption of cigarettes by just 1 unit. I hope we understand that, by just 1 unit. So that is what the marginal damage actually measures. Okay, it measures the cost of or the quantity of food, the good that the second person desires to consume. Okay, that he's willing to sacrifice in order to prevent the other party from consuming the good that is generating the negative externality. Okay, so now our assumption is based on 2 goods and 2 people, and one person doesn't even want to consume another good at all. So we are trying to look out for the allocation for quantities of food for the first person. We call it X1, and then food for the second person, we call it X2, and then the quantity of cigarettes for just the first person, because the second person doesn't want to consume any cigarettes. So the allocation will be given as X1, X2, and then Y1. Okay, when you add X1 and X2, you get a total allocation of food for these people. Now we have an available quantity of food. Okay, and the quantity of food that we are allocating it to these 2 individuals. Okay, so these 2 individuals, when we add their food allocation, it cannot exceed the quantity of food that we have in the economy. That is what is represented by X. If you look at the first equation, the PPF, it was X being a function of what? Y. So it was X is equal to F of Y. Now, when you add X1 and X2, it should be less than or equal to X. That is the total number of food, or the quantity of food that we have in the economy. The quantities that the 2 individuals will buy or will consume shouldn't exceed the available food in the economy. So when you add X1 and X2, it should be less than or equal to X. But because X is equal to F of Y, then we are saying that the allocation should be feasible if X1 plus X2 is less than or equal to F of Y. Okay, this F of Y is the same as the X that we had from the equation 1. Okay, so now we want to find the allocations for X1, X2, and Y1 that will be socially optimum, that will bring out the social efficiency that we are looking for. Okay, now we are taking the social welfare function to be of this form. Total welfare is a function of the utility generated by the first individual from the consumption of good X and good Y, and then the utility for second individual generated from the consumption of good X and then good Y. Now, the marginal welfare for both individuals will be greater than 0. The marginal welfare for both individuals will be greater than 0. What this means is that whenever one person becomes better off, the entire society also becomes better off. Okay, just one person becoming better off means that there's an increase in the social welfare. The W1 is measuring the marginal welfare of an individual. So assuming you are increasing your consumption by some small unit, what is the effect on your well-being? That is what W1 measures for individual 1, and then W2 will measure for individual 2. Okay, so they being greater than 0 means that whenever a single individual becomes better off, it affects the social welfare in a positive way. Okay, so you becoming better off means that the entire society is also becoming better off. So what we are trying to do is that here too we are faced with an optimization problem. Okay, for us to get efficiency, the allocation of these quantities of x1, x2, and y1, we need to make sure that we are doing this. We are finding the quantities that will maximize social welfare, okay, subjected to the feasibility constraint, this. So we want to maximize social welfare subjected to this constraint, okay. So get the allocation of x1, x2, and y1 that will maximize social welfare. So we maximize the social welfare subjected to the feasibility constraint. Okay, so we all know the drill. We form our Lagrangian function. We bring the objective function first and then the constraint. So here the objective function is the social welfare function. And then the constraint is going to be the feasibility constraint. So this one that we have here. So forming the Lagrangian, your L will be equal to the social welfare will come first. Then here we are using FY1 because for good Y, we only allocate it to individual 1. Individual 2 doesn't want to consume it at all. So your social welfare function comes, then you know the drill, lambda, then FY1 minus X1 minus X2. So this is the Lagrangian function. So we need to find the first order conditions and set them to 0. So we differentiate them with respect to X1, X2, and Y1. Then we equate them to 0. So let's start with X1. Differentiating L with respect to X1. Here, you see that this is a function of a function. Okay, when you differentiate the social welfare function with respect to U1, you get your W1. Okay, you get your W1. Then you differentiate the utility function with respect to X1, you get your U1X. So the first part here becomes W1 U1X. Then when we go to the constraint, we have minus lambda X1. So when we differentiate this with respect to X1, we will have negative lambda. So this is equal to 0. Then we come to X2. This one we are differentiating L with respect to X2. So W with respect to U2 give us W2. Then U2 with respect to X2 is going to give us U2X. Then this side, minus lambda X2 will give us minus lambda. So this is equal to 0. Okay. Then we go to Y. Okay, we go to the Y1. Now we are differentiating the welfare function with respect to U1, we get our W1, then with respect to Y1, that one to give us U1, Y. Then when you come here, this second individual two, though you don't want to consume your consume Y, you cannot avoid its consumption. You cannot avoid the effect of that consumption. Okay, so definitely when person 1 consumes Y, you also have an effect there. So when you differentiate W with respect to U2, you get your W2. Then with respect to Y, you get your U2Y. So this is equal to, when you come to the constraint, if you did differentiate this, okay, we have minus lambda F prime Y, F prime Y, okay, F prime Y, F prime Y. So this one too, these are the 3 equations that we have from the first order derivative. All right, so here we have minus lambda F1 because if you remember, we said F prime of Y is less than 0. Okay, F prime of Y is less than 0. That's why we have minus lambda F1 here. So now from equation I, we can make W1 the subject. If you make W1 the subject, we have, if you look at this equation I, we have lambda over U1X. From equation II, we have W2, making W2 the subject, we have lambda over U2X, lambda over U2X. So now we take these values of W1 and W2 and put it into equation I. So W1 is lambda U1X. So we will have lambda is lambda over U1X. Okay, so here we have lambda, the U1Y is there over U1X. Then when you come to the second term, W2 is lambda over U2X. So we have lambda u2y over u2x minus lambda f prime of y. Okay, minus lambda f prime of y. Now, if you go back to the equations, okay, the equation 4, the marginal rate of substitution for individual 1 was u1y over u1x. u1y over u1x. Okay, and then if you remember the marginal damage, I think that was equation 6. u2y over u2x was the marginal damage, and negative f prime y was the marginal rate of what? Transformation. Now from here we cannot see, we can get rid of lambda. We divide through by lambda, they will go away. So u1y over u1x is marginal rate of substitution for individual 1. Then u2y over u2x is the marginal damage. And remember we said u2y is less than 0. So it will be minus marginal damage. Then this side, the right hand side, will be equal to the marginal rate of transformation. So rearranging, we'll have marginal rate of substitution for individual 1 equals marginal rate of transformation plus marginal damage. Okay, plus the marginal damage. So this is what we've been able to arrive at. It means that before we can efficiently allocate these, get the efficient allocations for x1, x2, and then y1, this condition must hold. Marginal rate of substitution for individual 1 should be equal to the sum of the marginal rate of transformation and the marginal damage. That is the harm that is being done to the second person as a result of consumption of y by individual 1. So from here, what is going to happen is that we need to reduce food production. Okay, we have to reduce food production. If you remember, under the analysis of externalities, we said that when goods have negative externality, if there's a negative consumption externality, what happens? The consumer will tend to overconsume. Okay, the person will be trying to consume more of the good that causes the negative externality. But if you think about the first person, this first person wants less of the good that is causing the externality, and he'll be trying to sacrifice more of food just to cause the other person to reduce the quantity of cigarettes that he consumes. So there should be a reduction in food production just to encourage the other person to reduce the production and the consumption of cigarettes. But to the first person, he will just be consuming more cigarettes because the thing is generating a negative externality, and we tend to overconsume a good that generates negative externality. And to the second person, you don't like cigarettes, but then you'll be forced to engage in secondhand smoking. The person who smoke, and you have to just endure the negative externality. So algebraically, for us to get social efficiency for a good that generates negative externality, this condition must hold. Okay, this condition must hold. It is not like this under perfect competition. That is why we have externality being a source of negative and market failure. Okay, I will look at that shortly. So what did we actually arrive at? The efficiency condition is stating that, I am just reading what we have here. If an allocation is efficient, then the marginal benefit of a little more cigarette consumption by person 1, that is what the marginal rate of substitution measures. So that is the left-hand side, okay, should be exactly equal to the sum of the two costs imposed by the increased cigarette smoking. What are these two costs? The first cost is the opportunity cost of producing more cigarettes. That is measured by the marginal rate of transformation. Okay, so as you are reducing food, you are bearing a cost, you are bearing an opportunity cost measured by the marginal rate of transformation. And then the marginal damage is also a cost. Okay, whenever you increase the consumption of smoke, you are causing an increase in secondhand smoking. So there's going to be an increase in what? The marginal damage. So before we can have efficiency, social efficiency, then this efficiency condition must hold. The marginal rate of substitution should be exactly the same as the sum of the marginal rate of transformation and the marginal damage that is being caused by the consumption of the harmful commodity. Okay. So that is for the general analysis for social equilibrium. Now, if you take the right hand side for social welfare, if you take the right hand side, there's a sum of what? Marginal rate of transformation and marginal damage. We call it the marginal social cost. The marginal social cost. Okay, the marginal social cost. Now, the marginal social cost is measuring the cost to the entire society as a result of increased consumption of good Y by +1. So, if the first individual consumes more of cigarettes, then the total cost, okay, if the first person should increase its consumption of cigarette by just 1 unit, then the cost to the entire society will be measured by the sum of the marginal rate of transformation and then the marginal damage. Okay, the marginal damage. So that is the marginal social cost, the MSC. As soon as you increase your consumption of cigarette by 1 unit, you have to pay the opportunity cost. That is the cost to the entire society, the marginal rate of transformation, and also the damage caused by the second-hand smoking by the second person. That one too is a cost to the society. Okay. So this is the case where we consider the negative externality that is being caused by the individual, the consumption of good Y by the first person. Now let's look at what happens in a competitive market, in a market economy, where the person consuming the good generating the negative externality doesn't account for the negative externality. Okay, so what happens in a competitive environment? Now, for perfect competition, we all know that for profit maximization for firms do produce up to the point where the marginal rate of transformation is equal to the price ratio of the two groups. So PY over PX should be equal to the marginal rate of transformation. That is to the firm. Then to the consumer, okay, to the consumer. Assuming this individual has income M1, and then you want to consume a bundle X1 and then Y1. Okay, the person tries to consume out of the different bundles on the budget line that will maximize his satisfaction. Okay, so what will this person do? Now, the income that you have, as we all know, your total expenditure couldn't exceed that. So the total expenditure on the two groups, PX X1 and then PYY1, shouldn't be greater than the income. It should be less than or equal to income. So this person is faced with this constraint, and then he has or his preferences are given by this utility function. So you want to choose an efficient bundle X1 and Y1 to maximize this utility function subjected to the budget line. This is our budget line here. So if you remember, when we use indifference curves, the individual will maximize. The individual is going to maximize the satisfaction from consuming the bundle X1, Y1 when the slope of the indifference curve is equal to that of the budget line. And the slope of the indifference curve is given by the marginal rate of substitution. And the slope of the budget line is given by the ratio of the prices, which means that from the consumer's perspective, marginal rate of substitution should be equal to PY over PX. So if we compare this condition to that of the producer, here to PY over PX is equal to MRT. It means that MRS should be equal to MRT. This is under competitive equilibrium. Marginal rate of substitution should be equal to marginal rate of transformation. But if you compare this to the social optimum one, you see that for the social optimum one, they take into consideration the marginal damage. Here, they are not considering the marginal damage. So this individual is only thinking about the opportunity cost of his increase in cigarette consumption without accounting for the marginal damage. So he will just buy more than what the society deems fit. That is why the last time we met, we said that when the good is having a negative externality, they tend to produce more. If you are paying for the damage that you are causing, it will reduce the quantity of the good that you can buy. But here, under perfect competitions, they don't do that. They just pay for the opportunity cost of the good. Then they just move on. So it doesn't actually produce an efficient allocation. That is why we say externalities cause market failure. They don't efficiently allocate resources. You are supposed to consume less than what you consume under perfect competition. But for the first analysis that we did, that one, the marginal damage was actually taken into consideration. So that is the difference. Okay. So if the individual is consuming under perfect competition, you just consume too much of cigarette because he is not accounting for the marginal damage. But then if you are talking about the social optimum or social efficiency, we have to consider the marginal damage that you are causing too. So that is that. This is just a wrap up of all that we have done. So this is the end of our lessons on externalities. Okay. All right.